Hi, it's Carly McAvoy. In the last video, I showed you how to rationalize the denominator for expressions like this. And in this video, we're going to look at expressions that have two terms in the denominator. So what we're going to use is something called the conjugate. And the conjugate just has, it's like for a binomial, it has the same terms with a different sign. So what we're going to do is multiply this denominator by 4 minus the square root of 5. And of course, if we do that to the denominator, we have to do the same thing to the numerator. So we ended up doing that. We can think of this as distributing the 2 through here, and that would give us 8 minus 2 square root of 5 in the numerator. And for the conjugate, we're going to FOIL it, which means we're going to take the first terms. 4 times 4 is 16. The outside terms, 4 times negative square root of 5. The inside terms, the square root of 5 times 4, that's positive. And then our last terms, the square root of 5 times the square root of 5 is 5. But we also have 1 plus and 1 minus, which makes that negative 5. And so the numerator is not going to change. 8 minus 2 square root 5. And the denominator, your inside and outside terms, are going to completely cancel out. And what you're left with was 16 minus 5 here, which is 11. Now, in case you didn't catch it on another video, why does the square root of 5 times the square root of 5 equal 5? The square root of 5 is the same as 5 to the 1/2 power. So if you multiply 5 to the 1/2 power times itself, you get 5 to the 1/2 plus 1/2, or just plain old 5 to the first power, or 5. That's why we can take a radical, square root times itself, and get the radicand, which is the number underneath. In the second expression, we have the square root of p minus 7, so the conjugate is going to be plus 7. We're going to do that on the top as well. We always have to have that symmetry of bottom and top here. And so the square root of p times the square root of p, just like we saw down here, is going to be p. And the square root of p times 7 is going to be 7 square root p. On the bottom, when I FOIL this, the square root of p times the square root of p is p. My outside terms are positive 7 square root p. My inside terms are negative 7 square root p. And then negative 7 times positive 7 is negative 49. And now I'm just going to clean up the denominator, the top. P plus 7 square root of p, they are not like terms. I can't add those together. Those p's are different. And then down below we have the inside and outside terms once again cancel out. That's what conjugates do for us. And then we have p minus 49 here. And in this third one, we're going to again multiply by the conjugate. Because I have a plus, my conjugate's going to be negative. And I'm going to multiply by the same thing on the top. And notice I'm not taking the conjugate of the numerator. I don't care if there's the radical in the numerator. I'm only taking the conjugate of the denominator and then doing the same thing on the top that I do on the bottom. FOILing both of these out, on the top 4 times 3 is 12. And then our outside terms, 4 times negative square root of 6. Inside we have 3 square root of 2. And our last terms, we have negative and a negative, so plus 2 times 6, which is the square root of 12. We're not finished with that numerator, but all we did was FOIL. We're going to go ahead and FOIL the denominator as well. 3 times 3 is 9. We have negative 3 square root of 6. We have positive 3 square root of 6. And we have negative times positive, so negative square root of 6 times the square root of 6, which is just 6. Now, why didn't the top work out so nicely like the bottom's going to work out? Because these aren't conjugates. These being conjugates makes it work out so nicely down below. Well, let's do what we can with this one. We can't combine these two because they are not like terms. So nothing I can do there. and I can't combine these, but I can simplify this. So let's do that. The square root of 12 is actually the square root of 4 times the square root of 3. And that simplifies to 2 square root of 3. So I can just write it that way anyway. So what I have is 12 minus 4 square root 6 minus 3 square root 2 plus 2 square root 3. I'm going to just tell you something. These are all different, and we could maybe do some things to try to make those nice, but I'm just going to leave it like that. And on the bottom, I have these two things canceling out, and I have 9 minus 6, which is 3. Now, can I cancel this 3 and the 12? No, because this 3 goes here, it goes to the second term, third term, and the last term. You could go through and separate those out, but you don't really need to. What you need to do is make sure your denominator does not have a radical in it when you're finished. And I really wish this would look nicer than it does, but I pulled this off a site that is homework for my students, so I wanted them to see something that gets pretty darn messy. All right, hope you have a fantastic day. I'll talk to you next time.